So let me just say a few words about Bhupinder Singh, who's the first speaker today. He's from a company that called InTwin Insights, which is a consulting firm. Bhupi spent a long career at Bentley Systems, which is a company that leads infrastructure engineering software. I've known him for quite a while and followed his work, very interesting work in digital technologies applied to engineering and construction. So Bhupi, take it from here, please. Okay.
I am going to share it out. Great. Well, good morning, good afternoon. I'm speaking to you from the West Coast in California, and it's a pleasure to connect with all of you. I presume that my audio and video are working. I'm going to take you on a 30-minute journey on the digital transformation as it applies to the built environment. As Atul mentioned, I've spent pretty much my entire professional career applying computer science to civil engineering, and that's kind of my background, and it's been a passion of mine. So let's jump right in. Some sobering statistics for all of us, and if you look at what this slide is trying to say, we are going to go from about 7.8 billion people in the planet by 2030. They anticipate us growing to about 10 billion. So we're going to add about 2 more billion people in the next decade. And we're going to move at the same time, about 3 billion people are going to move into the middle class. All of them, having aspirations, legitimate aspirations of refrigerators and microwaves and cars. And at the same time, we have urbanization, and a study that was done says that it is the equivalent of 6 Europes if we wish to satisfy the infrastructure needs that would arise from this explosion. So just think about that for a second, the magnitude of what is required of us to solve this problem that we will face. And BC is before COVID. So our lives before COVID, there was an inexorable migration to cities. And now we question that. Some of us who lived in cities and are now seeking to migrate out, but I do think we have short memories, and in a few years, people will flock back to cities for many reasons. Not the least of which actually are climate migrants. They're migrants that come for jobs, but they are climate migrants. Just a couple of years ago, those of you who were following this, understood that Cape Town was going to run out of water. And you look at coastal floods, you look at other natural disasters. By estimates that people are talking about with flooding, the rising sea levels are going to cause issues. Places like Bangladesh that already are under severe stress with respect to the infrastructure requirements are going to be facing even more pressure with rising sea levels, and what they have to do in logical terms is become climate migrants. And where would they migrate to, right? Already Dhaka has gone, I guess in the last couple of decades, it's quadrupled to 20 million people, and it's already unsustainable. You're going to find climate migrants becoming a problem for all of us to deal with. A few slides that you may have come across in terms of, as I said in my overview, the world took a collective breather during COVID, and many of us enjoyed views and air quality like we had not experienced, for many decades. And this is again, stuff you've seen. This is Venice. This is New Delhi, where Atul and I went to college a while ago. And unfortunately, as you look at all of how spectacular this looked, in fact, there were cities in northern India where they could see the Himalayas, which they had not seen, for 20 or 30 years. And the challenge we have is, guess what? We're battling ourselves back to how it was. Today, the air quality, the pollution levels, if you look at anything that is being shown in China, the industrialization is back. Those of you who are living in urban areas, I was in Sacramento the last few days, and the governor's announced a lockdown, but the highways don't look any different, and you wonder where everybody is going. Right? So are we doomed to just go back to living and not understanding the lessons learned? And looking at the lessons learned, the other sobering statistics from California, where I'm at, is, the world is shaking, burning, and flooding. This is some sobering statistics from the city of Houston, which had Hurricane Harvey just a couple of years ago. The costs to us, right, while we look at the deficits and the needs, the costs are also rising. By some estimate, the cost for Hurricane Harvey was over $100 billion, right, of floods. And if anybody thinks that these natural disasters are not going to increase in magnitude, there are plenty of studies I could send your way. Okay, well, I could go on, and I don't want to depress us, any more than we would be today with the COVID lockdowns. But in 10 years, and then if you look at 2010 to 2020, the deforestation has only accelerated in the Amazon. So if we take a step back and look at all of that as a challenge for us on the planet, and we reconcile that to what the United Nations had as goals for all of us, sustainable development goals, and these 17 goals they had, from eliminating poverty to clean water for everybody on the planet, you really consider that infrastructure is directly related to our quality of life. So for every one of us, the better quality infrastructure, the better the quality of life. And as a civil engineer, that's something that has been significantly motivating. And then, having the good fortune of combining it with computer science. And I think Atul and I took a Fortran course in our undergraduate college together. It's just the marriage of these two fields is where I think magic will happen. And when you look at what the infrastructure deficit is for everything I talked about, they are saying that we have a $1 trillion deficit, or $15 trillion deficit. And I think this was a World Economic Forum report. I think McKinsey has different numbers. And depending on how you count it, they're really large numbers. The gap between what we can afford and what we can spend. And of course, that's the deficit. And then you may have seen, a developed country like America with the crumbling infrastructure. For those of you who have had the privilege of being able to travel around the world and been to places like Singapore and many places in Europe and the Middle East, the sparkling infrastructure that they have there, we can only dream about. And I'm hoping that in the post-COVID world, this is from the Wall Street Journal a couple of days ago, that in the completely polarized and divided world we have in this country, that we could all unify around an infrastructure bill. The unsexy world of infrastructure can be something that can bring the country together, and the country can spend some money. So the other aspect, as I get to the answer, is as you follow the money, the other very interesting thing that's happening as a market trend and a market driver towards the digital transformation is the investors, whether that's BlackRock or the pension funds, are all getting into this sort of ESG and sustainable, and driving down to net zero. So when money starts talking, companies listen. And the Climate Action 100 Plus, which lists out all the investor initiatives that are driving investments, now companies are following up. So every day you go by reading about commitments to net zero, whether they're oil and gas companies, whether they're high-tech companies, whether they're car companies. Every company is falling over themselves in posturing, wanting to get to some sustainable development and net zero. The question is, how are they really serious, or are they only saying it and paying lip service because that's what the investors want to hear? I think from my conversations with plenty of these companies personally over the last couple of decades, they are serious. They just don't know how to get there. And part of my thesis is going to be digital transformation is the only answer for us. And I'm a true believer in the technology disruption, in digital transformation. I think Mark Andreessen said, every company's future is to be a software company. And it doesn't matter whether you're building transformers or you are an asset owner, the future for you is digital transformation. And specifically, the rest of my conversation over the next 15 minutes or so is going to get into what I call digital twins, and what the definition is and how can it really help us bridge this gap. So why now? From a market standpoint, it's a confluence of many different things that you're all probably pretty familiar with. Storage and compute costs getting as close asymptotically to zero. Sensors, the numbers are staggering in terms of IoT. Of course, plenty of these sensors are going to go into your refrigerators and microwaves and your Fitbits, but plenty of them are going to be in your buildings and plants and bridges and cars, and they're going to be emitting tons and tons of data for us to then make sense of. You couple that with the ubiquity of being connected wherever you go. You couple that with drones that you can, cost effectively fly anywhere, whether that's a dangerous area or it's an inaccessible area or a construction site. And you couple that with machine learning. These are all the macroeconomic trends that are making this transformation possible in the industry of built environments. To some definitional terms, my presentation will have lots of links in there because I would assume that for this audience, you're sort of getting an exposure to an arena perhaps and an industry that you aren't quite familiar with. This is a very ambitious effort by the UK, where they actually have a national digital twin initiative. And their website is a wonderful place for you to go learn about. If you just key in the Google Center for Digital Britain, they have lots and lots of information that's informational, what they're trying to do as a nation, how they want to build this national digital twin. And some definitions, first of all, for you is obviously, when I say digital twin, it's a fairly intuitive idea. There's a digital representation of a physical object or a process. A couple of things to understand is that throughout the infrastructure lifecycle, there will be multiple twins. People think that there is the digital twin, but I think a key idea to understand is we will have multiple digital twins depending on the purpose And the whole idea is that there's a two-way connection between the physical and the digital. So the physical has IoT and sensors to the digital, and then the digital can consume information and then control the physical back. So those two-way connections are the magic with the digital twin. And that when we say the word twin, we need to understand that this is a near real-time representation of what's actually out there. And that's a very ambitious statement to make, right? You can think about your digital twins today, that as you sensor yourself and you have the feedback loops, right, when you're working out or when you go to the doctor's office or when you look at your CAT scans, those are all, every snapshot you take of yourself, a digital snapshot, if you think of it being continuous, then now you think about that digital twin of yourself. But you could have an endocrine digital twin, a skeletal digital twin, a muscular digital twins, and each of those are different systems of yourself. Similarly, for a building, you could have the electrical digital twin, the structural digital twin, the HVAC digital twin, and they can all then be system of systems, is the way to think about that from a physical infrastructure standpoint. I think the other thing to think about is you really can have digital twins not just when something is built, but starting from project planning. So if you look at this infrastructure lifecycle, you can have digital twins that can begin even before, during your planning exercises, right? What is the difference between a CAD model and a digital twin is the fact that it is incrementally changing. As changes are made, it's synchronizing back. So all of this becomes possible with a backdrop of federation, right? As a strategy, you will have multiple digital twins and need to federate changes across them. And also the concept of openness, because a single vendor will never be able to provide you with the size and scope of what digital twins really need to deliver value to. So therefore, you will find lots of initiatives. In fact, there are plenty of global initiatives around openness, where the governments that are getting to smart cities are driving, where the companies that large infrastructure, oil and gas companies they're all driving around the concept of how can I create taxonomies for defining and describing things in an ontology that is sort of an open standard. So therefore, we can all agree on the semantics of what we are describing, and then different vendors can offer different solutions that can then link all of this together. So those are all, very, very important ideas and a backdrop to a digital transformation solution. So let me just now speak about some tangible use cases of digital twins in the different phases of the life cycle. If we start with design, and certainly my career over the 30 plus years has seen the transformation, the disruptions that began with CAD, which really took what engineers were doing on paper. When we went to college, we started with big sheets of paper and drafting. The first arena, the first wave of these digital transformation was really taking what people did on paper and then putting it on the computer. And then they realized, well, we could do more than just mimic what the paper workflow was. And then they got into what in our industry is called BIM, which is information modeling. And you actually build the 3D models. And then they got into simulation, which is let's not just model how it looks, but also try to model how it behaves. So the whole idea, but this transformation now with digital twins is that this becomes a continuous and improving and optimizing, virtuous cycle. So you just don't do it once, but you do it multiple times, and you can iterate across multiple disciplines. You can do it between and optimize between different disciplines versus just doing it across one. And there are plenty of software companies that are offering digital twin simulation software across, automotive, to AEC, to healthcare. And this area has probably seen the most development just because of the fact that computers have been used, right, in very sophisticated ways. But then the next two phases for the infrastructure lifecycle is where it really gets interesting, because construction, there was a McKinsey report that, the productivity gains in construction since the 1930s has been abysmal, right? There's study after study that tells you that 40% of this stuff goes to waste. And the problem has been, it has all been manual, it has all been with paper, right? So if you look at the mechanical industry and their leverage of technology that went from CAD to CAM, the minute they could drive the machine from the model is when huge innovation happened. Similarly, the digital twins for construction, there's massive innovation where now the model is going from design to the bulldozer without human intervention. And the bulldozer's blades are going up and down doing the cut and fill automatically, right? So there's a virtual digital twin for construction being driven by the design digital twin. Think about it from a standpoint of drones flying construction sites and capturing as constructed every day what's changed and being able to compare that against a model. So having these virtual sequences and 4D digital construction, this is massive amounts of venture capital is going in here. Huge companies are investing in this space. So digital twins for construction is the one big piece that was missing in the whole digital workflow, right? And then the other aspect that's really happening here that's disrupting is modular construction. So people are fabricating and assembling on site. So these big drivers are the other arena of massive innovation. And in operations, all the way to the right, where most of your money gets spent, there's significant amount of digital twins as well. So think about using drones to go inspect a bridge, using drones to go inspect transmission lines. Now, that's all happening, but you really need a digital twin of the transmission tower to know now what, right? You're going to capture photographs, you're going to go and capture information, but in order to make sense of it, you've got to then superimpose that on a digital model, which you may not have. So there's a whole host of software solutions coming out around digital operations that combine machine learning, combine augmented reality, and really are trying to get us to this, what I call, going from hindsight, look at what happened, create insights of what's happening, and then ultimately, it's all about foresight to prevent stuff from happening in advance, right? So if I can come in and proactively do something before something is going to fail, that is the ultimate promise. And of course, you get that by combining engineering information, combining that with sensors, and combining that with enterprise. So this combination of ET, IT, and OT is what you call it, is getting you to this wonderful universe. So to close with some really tangible use cases of this, being deployed today. This is actually a software company that was competing with the company I worked for, based out of the UK. This is a Middle East oil and gas operator that has this virtual dashboard. They're doing remote operations of their oil and gas plant, right? Real-time information. And that remote operation, now I was talking to a senior executive for an oil and gas company. They were on this sustainable net zero initiative, and they wanted to remote monitor their offshore plant. To save one helicopter flight, right? They were calculating the amount of the carbon footprint of one helicopter flight. And if you could save a helicopter flight out to go see what was there and remote operate the digital twin of the oil and gas plant, because they have fiber going to that. Think about all the unplanned, if they could extend the useful life of their offshore plants by another 10 years, that was infinite money they could then, afford to spend on a digital transformation effort. Ultimately, they're engineering companies that are going to offer uptime as a service, right? These industrial companies that are selling you transformers to the substation have tremendous new business opportunity to sell power as a service, uptime as a service based on these digital twins. Some more examples of it in other industries. Water, you've seen this, water is the new oil. There's digital twin solutions for water. There's some estimate that, in various countries, between 5 to 70% of the water is lost. They call non-revenue water. This is water that does not get to the tap from the source, either through leakage, through bursts, and solving that problem through digital twins. There are tremendous amount of solutions that can come with sensors, comparing the simulation models, and so many cases in these cities, these water infrastructures, 50, 100 years old. So how can you cost effectively do all this in a digital twin environment is a pretty significant effort. The last one is smart grids. People are now putting solar panels. Grids were not designed to deal with two-way power, right? It was central power and then nodes of consumption. Now you've got generation nodes coming up, and utility companies have no idea how to deal with all of those things. So being able to build a smart grid and then simulate what happens if somebody puts in another generation in that grid and deal with this two-way stuff is a significant amount of development efforts. Smart cities, there's a report here on the Cisco's Internet of Things platform. The city in Portugal lowered their water management cost by 30%. So we really can look at, as I wrap up my 30 minutes here, massive amounts of return on investment with digital transformation to perhaps, the built environment for all around us. The ROI is there, whether it's extending the life of aging assets, or whether it's helping us migrate to, renewables, or whether it's, keeping our bridges and tunnels and buildings, more efficient, more cost effective, more sustainable. So a call to action for all of us, because the enlightened owner, whether that's the Metropolitan Transit Authority, whether that's the city of San Francisco, having enlightened owners demand digital twins through their supply chain and use these digital twins in operations is what the promise is for all of us. I think I'm reaching my 30 minutes of time here, but hopefully I gave you a pretty quick journey through what digital transformation is to the built environment, why it's important, and why it's the only way that we'll be able to solve the demands that it's going to put on the planet, for the decades to come. Atul, back to you.
Great, thank you. Wonderful, eye-opening presentation. Some aspects of the presentation were awe-inspiring. So, do you have numbers on the 2 billion population growth you talked about? Is that going to impact the entire world, or certain parts of the world more so than the others?
Well, certainly it's going to impact parts of the world that can least afford it.
Yeah, that's what my fear was.
The tragedy is growth is happening where the infrastructure is the weakest in many cases, right?
Yeah.
And therefore you have more migrants and then more pressures in other parts of the world. So you really can't think that, oh, it's somebody else's problem.
Yeah.
And then you couple that with the cost. In fact, the cost of fixing built infrastructure sometimes is much more expensive than building new infrastructure.
Mm-hmm.
Because it's so much more difficult to go in and fix a bridge versus in some cases, building new stuff. So you've got costs regardless of population.
Yeah. Let me ask you another question then.
Yeah.
So the way that digital twins help us alleviate the demands on infrastructure build over the next 20 years, 10 or 20 years, is by reducing costs in planning, build, and maintenance or operation, and being able to build something that actually meets the requirements. I mean, what are the ways that the first half of your presentation showing the challenges and the second half showing the advantages of the technology? Give me some more insights on how the technology helps overcome the problem.
Right. So if I start with operations, right?
Mm-hmm.
If you try to quantify the costs of unplanned downtime,
Mhm.
right? When your plant goes offline for a period of time because some equipment failed, right? And then you now have to react to unplanned downtime. If you had a digital twin of your plant, right, with real-time information and sensors, and it's giving you some information such that with insights and a dashboard, you can proactively fix something before it fails,
Mhm.
right? Preventing unplanned downtime for a pharmaceutical plant, for example, right? If you can move that needle by some percentage points, is massive amounts of benefit from them from a cost standpoint. So in order to go and prevent unplanned downtime, you really need to get the sensor information, and then you need to see it in context to, right?
Yeah.
What? And so that's one example. Let me give you another example of a digital twin and corrosion, right? You just think
Mhm.
about corrosion in pipes, right?
Yeah.
In a refinery or whatever. Now, people have gone out and measured corrosion by doing acoustic stuff through a pipe, right?
Yeah.
Now, you've got all this reams of data, and really hard for you to now to create insights from that.
Yeah.
Or what do I now do with all of that corrosion information? So the digital twin idea is that you get your plant, you capture your digital twin of your plant, you superimpose the corrosion information so that you see it in the pipe, right? This particular pipe has got this type of corrosion characteristics. You can run a simulation based on that. It's now this diameter pipe, it's behaving like this diameter pipe. And now with a certain amount of capital, you can now decide how to do corrosion management
Mhm.
more effectively based on that digital twin. So that, is billions of dollars of savings that you could have as a value proposition, right? I could go on. There's lots and lots of use cases during operations, but the whole idea that you can have more effective and more efficient, extend the lifespan of your existing assets, uh, inspections with bridges, right? You catch a drone, you look at a crack on a bridge, you can see the size of the crack, you do machine learning against it. You can now run a simulation on the bridge, do it through the digital twin
Mhm.
of, does this really require an intervention or not, right? In order to do that, you need to simulate on the digital twin that this bridge is now going to behave this way based on the characteristics that I'm capturing from that digital workflow.
Good. Good. All right. So we have one question from the audience.
Yeah.
You can see the question, right?
One
It's
second.
talking about GE having a negative experience with digital twin modeling for jet engines. Uh, any lessons learned from that experience?
So certainly there's positive and negative experiences with most companies, right? With the digital, if you look at GE made a big splash with their Predix platform, right?
Yeah.
They
Yeah.
spent lots of money. Was it a wrong idea? No. Did they go about it? Were they ahead? Either you're ahead of the time to do something, or you do it in a way that, as an industrial company, trying to present yourself as a software, right? Transforming yourself as a software
Yeah.
company,
Yeah.
and whether you can be viewed by the market as something other than you're selling equipment. Now, on the other hand, you forget GE, and let me give you the use case where everybody likes to talk about it: Rolls-Royce, right?
Mhm.
Rolls-Royce, you may have learned about this. Rolls-Royce went from selling engines to selling flight miles.
Mhm.
And that flight mile business model was, and now obviously they're hurting because the planes aren't flying, so their revenue went down, right? So you got to be careful when you have a consumption-driven business model. What happens when the consumption goes down? But the only reason Rolls-Royce was able to do that is because they had the engines sending them real-time information, right? They had a
Yeah.
digital
Yeah.
twin where they could then say, my job is to keep that engine running as long as possible, right?
Right. Right. Yeah.
So you do have uh, use cases where sometimes people went ahead of the headlights, and
Yeah,
you can outrun your headlights, and then you can say, we were. If you look at Google with their smart city and sidewalk labs, and there are plenty of
yeah,
examples where you can run ahead of your headlights, either politically, technologically, commercial model, right? Each of these can be an overreach sometimes, right? But it's an inexorable drive of where we're headed with this, I think.
yeah, yeah, yeah. So a comment, I think not a question, but interesting one that HP has a per page model for printer ink sales as well. I guess that applies to businesses, not consumers. I mean, they don't offer me as a consumer a per page model, but yeah, to businesses, of course, if they have the maintenance contracts for your printers and your copying machines, they can offer that, right? It's but whether they do it using digital twin technology, I don't know.
Yeah, I mean, see, the thing is, everything is censored, right?
Yeah.
If you're collecting data back,
Hmm.
who's using what when? If they're getting data back on each printer, sending them how many pages are being printed,
Yeah.
right? We're used to a consumption model with our lives, whether it's the electricity you use, whether it's the printer ink you use,
Yeah.
and that same consumption model uh, is going to extend to uh, very innovative business models with really infrastructure as a service, right? If you think about it, the city of White Plains, New York, really has no expertise in owning a water treatment plant, right, or owning a substation. And if a company can offer power as a service or water as a service, and you're shifting risk and value,
Hmm.
and then they can then invest in the technology for you.
Hmm.
And yeah, obviously, you can get into a lot of questions about public-private partnership. How can it work? I think there are lots of experiments that are going to happen with this over the years,
Hmm.
uh, where that can spur. Uh, the digital transformation has to make economic sense,
Yeah.
right? And somebody has to pay for this.
Yeah. Good. You alluded to briefly in your talk about digital twin models for systems of systems for a human body.
Yes.
Are you aware of people doing that work?
Well, certainly, I haven't paid that much attention to uh, how these things are interplaying, right? I'm just
Mhm.
observing the
Yeah,
fact that your iWatch is, I mean, there's, I was reading an article about smart homes for the elderly now,
yeah,
right? Where these sensors are baked into everything
yeah,
and are constantly being monitored. It's a digital twin of your house and a digital
yeah,
twin of
yeah,
the human
yeah,
body
yeah.
with getting uh, a caregiver being looking at all the data,
Right.
right? Looking at your urine. I mean, there's everything is being censored, right?
Yeah,
And getting some proactive
right,
intervention.
right. Yeah. So sensor-driven modeling is a very interesting, very fast-growing aspect of digital transformation across many industries. Yeah, and I think that's where we get lots of data out of sensors, and now we have the tools to analyze the data in near real time and make adjustments, whether it's in a repair schedule or a design or a maintenance of a building, or whether it's a human body, right? So
Yeah,
yeah,
the challenge I've seen is the data is coming in, and the challenge is now how to create insights,
hmm,
right? Because data is just going to be data.
yeah,
To derive insights from it requires, um, right, a whole a whole lot of stuff there.
yeah,
And I think in the built environment, especially, right, is this good or bad?
yeah,
I just was talking to somebody last week where they're talking about acoustic data,
right,
right? You have acoustic data, and there's good acoustics and bad acoustics, and then machine learning being applied to just sheer acoustic information.
Yeah.
Apparently in Nigeria, the oil gets stolen along the way, and they drill micro holes through these pipes to, and then apparently there's an acoustic signal from that, and the company is trying to go out and sell, so there's just tremendous use cases on acoustic sensors,
Yeah.
right? In a plant, you can imagine, right? There's a good sound and a bad sound,
Yeah. Yeah.
and you can have all sorts of sensors, from stuff like that.
You're taking me back to my undergrad mechanical engineering days.
Exactly, exactly.
All right. Good. I think we had a very good discussion, a great presentation followed by a great discussion. Thank you very much, Bhupi. You're welcome to stay on if time allows,
Yes,
listen to some other talks from other industries.
yes, indeed.
All
Thank you
right.
very much.
Thank you.